is Algebra, lesson 7.2. We're dividing monomials. You will all think this is not difficult because you have done things like this already this year. But I will, we'll show you again. The first sample would be this. G to the third, h to the fifth, over g, h to the second. And I want you to divide this. We've done this before. Do you remember? Now here's what we do. Let's do it out the long way. One time so you can realize what we're doing. Is this not g times g times g times h times h times h times h times h over g times h times h? Isn't those two things equal? Right? So then, what do I do here? What do I do with this thing? Gone, gone, gone. What's that leave me with? G squared h to the third on top of 1, which I can leave out. There it is. Right? Super simple. But we've done this, so that should not be a problem. So rather than for us to do it this long way, what can we do? You go like this. You go, there's 3 g's on top and 1 g on the bottom. In your head, you go, when I eliminate the pairs, what's left? 2 g's on the top, right? And then when I go h to the fifth over h to the second, when I eliminate the pairs, what's left? H to the third on the top, and there you have it. Does that make sense? I mean, this is not difficult. We have done this. Okay, try this then. What about this? Let's go k to the 7th, m to the 10th, p over k to the 5th, m to the 3rd, p. Simplify that for me. So here we go. Without doing it the long way, k to the 7th over k to the 5th, when I eliminate them, I'm going to have k squared where? On the top. M to the 10th over m to the 3rd. When I eliminate them, I'm going to have m to the 7th on top. I have p over p. What does that do? Don't forget, it's not that they become nothing, right? Because it's important. If they became nothing, then that would mean this is a 0 down here, and then the whole thing wouldn't make any sense. So they become 1s, right? That's why they're eliminated, because they become 1s. And when you multiply anything by 1, it just whatever it was. So they are gone because it ended up being 1 over 1. So I have k to the 2nd over m to the 7th over 1, which is just this. Agreed? Did everybody get that right? No? Okay. Okay. What about this? A power of a quotient, right? I'm going to show you this one. I'll show you this one. It's easy. It's real simple. If I was to write this out the long way, what would it look like? Wouldn't it be 3p to the 3rd over 7 times 3p to the 3rd over 7? Wouldn't that be what that is? Right? And then if I was to write it out the long way, I would actually have 3 p's each time. But either way, how do you multiply fractions? What do? How do you multiply fractions? You don't? How do you multiply fractions? No, how do you multiply fractions? Multiply across the top and you multiply across the bottom. 1/2 times 1/3 is 1 times 1 is 1. 2 times 3 is 6. 1/6. Right? You just multiply across. That's how you multiply fractions. Remember? Remember? That's how you do it. So, if I have this, which turns into this, I'm just going to multiply across. That would be 3 times 3 is 9. P to the 3rd times p to the 3rd is p to the 6th over 7 times 7 is 49. And I'm done. That's the answer. So, let me give you one. Try 3x to the 4th over 4 to the 3rd power. Do I need to write this out the long way? No, I don't. I shouldn't. I'm going to take whatever this is up here and just do that 3 times and do whatever down here 3 times. So 3 to the third power is, it's almost like the distributive property. 3 to the third power is 3 times 3 times 3, which is 27, right? And then x to the fourth to the third is x to the 12th. Remember, powers of powers, you multiply. So is x to the 12th over 4 is 3 gets distributed on there too. What is 4 to the third power? 4 times 4 times 4 is 64. How many of you got 27 x to the 12th over 64? Do you understand how to do it now? Awesome. Do another one. It's almost like you distribute that squared to everything. 5 squared is x to the 5th squared is x to the 10th. Y squared is y squared. 6 squared is 36, and we're done. How many of you have 25 x to the 10th y squared over 36? Good. Okay. Okay. Another one here. I think we've dealt with this. It may not have been you. It might have been 7th grade this year so far, but I'm going to give you a nasty one here. Ready? Do you remember, what do you do when there's a 0 power? Do you remember this from last year? I'm going to show you something, okay? I'm going to show you this one time, okay? Let me do this for you. One way of, I'm going to come back to that. One way of doing this, what if I have x to the 3rd over x to the 4th? What do I do? I'll go x squared. One thing I can do is go, it's x to the 3rd, isn't it just going to be x to the 3 minus 2? Isn't that what it's going to be? Isn't it going to be x to the 3 minus 2, which is x to the 1st, which is just x, right? If I have x to the 15th over x to the 12th, isn't it going to be x to the 15 minus 12? Don't you agree with that? I mean, like, because it's going to be x to the 3rd. Do you all see what I'm talking about here? Do you agree? Okay. So then doing it that way, what is x to the 3rd over x to the 3rd? Isn't it x to the 3 minus 3? Isn't that true? Right? I mean, the rules don't change just because you kind of, you know what I mean? Like, that's how you do it. So then isn't this x to the 0? It is. So then what is x to the 0? It's not 0. Is x to the 3rd over x to the 3rd 0? What is it? It's not x. What is it? Anything over itself is... What is 5 over 5, people? 1. What is 17 billion over 17 billion? What is x over x? What is x to the 3rd over x to the 3rd? Anything over itself is 1. So anything to the 0 power is 1. So when you go back to... that, this whole thing is 1. The whole thing is 1. Anything to the 0 power is 1. It's a rule. And I just showed you why, right? I did just show you why, and that is the reason. That's just how they write it. Anything to the 0 power is 1. If I have x to the 1st, then it's just x. But x to the 0 is 1. Anything to the 0 power is 1. You just have to memorize that. I can't make you memorize that, but you need to. Okay? Okay, here's where things get a little dicey. Okay, you guys like dicey? No, you shouldn't like dicey. Here's dicey. I do believe we did this a little bit last year. I will show you. Okay, I'm going to show you again. X to the 5th over x to the 3rd. Pay attention. For real, watch the process. Okay? This is going to be x to the 5 minus 3. Do you agree with that? That's going to end up being, when you eliminate them, it's going to end up being x squared, which is 5 minus 3. That's how you can do it. So what about if I have x to the over 5 to the x to the 7th? So isn't this going to be x to the 5 minus 7? Isn't it? Right? Don't you agree? It's the same thing. So then it would be x to the negative 2nd. Because once I eliminate all this stuff, where do I have? What do I have? When I eliminate, when I say simplify that, what do you end up with? I don't have negative 2 on the bottom. I end up having what? Okay, forget the rest of this. Forget this. Forget this. X to the 5th over x to the 7th. Are you going to make me write this out the long way? When I eliminate the pairs, what do I have left? I don't have a number 2 anywhere. What do I have left? When I eliminate this, is there going to be a number 2 somewhere in this? I'm going to have x to the 2nd. Where? On the bottom. I'm going to have x to the 2nd on the bottom. Agreed? Right? True? Right? What goes on top? A 1. Right? So then, we just decided that x to the 5th over x to the 7th is x to the 5 minus 7, which is x to the negative 2nd. This and this are identical. I will show you again. Okay? If I end up with this, y to the negative 5th, that is equal to 1 over y to the 5th. If I have a negative exponent, it means that it's the same thing as 1 over that variable to the positive exponent. That is true. M to the negative 8th is the same as 1 over m to the 8th. Make sense? It's something that you're not used to, so you can't tell me you don't understand. You just have to learn it and memorize it, right? Get used to it, because that's the truth. So then, if I was to do this, if I was to give you this, let's do a good one here. I have n to the negative 3rd, p to the 4th, over r to the negative 2nd. I'm going to show you something else here. Okay, so watch. This n to the negative 3rd, if I was to tell you, the instructions would say, I want you to write this fraction for me without using negative exponents. I want no negative exponents. Okay, I want none. What that means is that I got to get rid of that negative 3. What does n to the negative 3rd mean anyway? Doesn't mean 1. 1 over n to the 3rd, right? Isn't that what n to the negative 3rd, didn't we decide that? That equals 1 over n to the 3rd? We decided that. So then, I'm going to take that n to the negative 3rd and flip it down and make it positive. So I'm going to erase this and now put n to the 3rd down here. And it would be a 1 up here, but we don't need to do that right now. Agreed? Makes sense? Okay. I have r to the negative 2nd on the bottom. What you do with that baby is you flip that baby to the top and you make it a positive. So then you're going to erase this r to the negative 2nd here and put it up here, r to the positive 2nd up there. And my new answer is r, well, you put p first, right? P to the 4th, r to the 2nd, over n to the 3rd, and that's my new answer. If I ask you, that's if I ask you to write this stuff with no negative exponents. Make sense? Okay. I also might ask you to do one of these. I might say, actually, hold on, let me make sure if this might be the lesson tomorrow. If it is, I'll wait. Okay, another thing that they might ask you to do is they might ask you to give this. I'm going to go x to the negative 4th, no, x to the 4th over y squared z. And I might ask you to write this polynomial, this monomial, without the fraction bar. In other words, I don't want to look at a fraction. I want you to give me a straight polynomial or straight monomial. Does that make sense? Okay. Here's the deal. How do I put that? How do I get, in other words, I can't have a denominator, right? So how do I get rid of that thing? What do I do with it to get rid of it? Flip it up and make it, so it would be x to the fourth, y to the negative second. That gets rid of him. Flipped him to the top up here, right? And then what about the z? You wouldn't put negative z, you'd put z to the negative first, right? This is already z to the first, it's just invisible. But now you're going to go z to the negative first. And there it is. This and this are the same. One is with a fraction bar, one is without it. Does that make sense? You have to be able to play with this and flip these things up and down, and it's no big deal. It's not a problem. Let me give you an example. Let me give you one and see if you can do it. They want this one to be no negative exponents, okay? 2a squared b to the third c to the negative fifth over 10a to the negative third b to the negative first c to the negative fourth. I love it. I better do this one for you. I'm going to do it for you. This is one more time. One last one I'm going to do for you, then I'll let you guys have a few. They're saying no negative exponents. Do you see any negative exponents? I see lots of negative exponents. Got to get rid of them. Do I have to deal with those? No. This? No. I see this right here. 10, a to the negative third. So it's just a to the negative third. Leave the 10 alone. A to the negative third. What do I do with that guy? Flip him up and make that a, make those a's positive. So there was a squared up here. I'm going to get rid of that guy here. He's gone, and add 3 more, right? So now it ends up being 2a to the fifth. Agreed? Okay. With the b to the negative 1, what do I do with that guy? Flip him to the top. So what am I going to do with this? Add 1, so it's b to the fourth. I have c to the negative fourth here. I'm going to flip that up and make that a positive 4. But, oh, wait a second. There's negative here. What am I going to do with that guy? Flip him down and make him a positive. So it actually ends up being c to the fourth over c to the fifth. Does that make sense? Does that make sense? Okay. Because I flipped them. I flipped them around. So then when I reduce this stuff, what do I end up with? When I reduce that stuff, it ends up being a c on the bottom. Right? A c on the bottom. I still have my 10 down here. I should reduce this, making this a 1 and making this a 5. So my real final answer would be a to the fifth, b to the fourth, over 5c. That would be the answer to this. I'm just flipping stuff around. You know what I mean? Is this hard arithmetic? Is this too hard of arithmetic for you guys? No. Do you need a calculator for this sort of stuff? No. It's just understanding that you need to flip stuff around and follow the directions. Sometimes they want you to have no negative exponents. Sometimes they want you to have no fraction bar. It just depends. You can flip stuff around. You know how to do that. Okay, now you guys try one. Let's do 4b at the bottom of 411. 32a to the negative eighth, b to the third, c to the negative fourth, over 4a to the third, b to the fifth, c to the negative second. I want no negative exponents. Okay? No negative exponents. Any negative exponent, you got to fix it around so that there's no negative exponent. All right, here we go. You're watching. Even if you're not done, you're watching now. I would, I was wrong. I would start with this. Let's get rid of that. 32 over 4 is 8. Draw the fraction bar. I have a to the negative eighth on the top, a to the third on the bottom. I'm trying to get rid of the negative exponents, so which one am I going to deal with here? Negative 8. I have negative 8 up here. What am I going to do with it? Flip it to the bottom. What's that going to do? Combine. It's going to combine that a positive 8 with a 3, making it a to the 11th on the bottom. Agreed? Does that make sense? Do you all see that? And does that make sense? Okay. So they're gone, right? They're easy. They're done. Those guys are done too. I have b to the third and b to the fifth. All I need to do right now is just reduce, right? There's no negative exponents, so I just need to simplify them. When I eliminate them, what does that leave me with? B squared on the bottom. B squared on the bottom. They're gone. Okay, this is an ugly one, right? Because what do I have to do? This one's kind of, you got to wrap your brain around this. I have to flip that baby and flip this baby, so it actually ends up being c squared over c to the fourth. Agreed? Another way of doing this, is if you want to not do that extra step there, you can go, this is going to end up being c to the negative 4 minus negative 2. Isn't that how it works? Whatever. If you want to do it the other way where you think of it, whatever. Okay, so it's going to end up being c squared over c to the 4th. And so when I reduce things, what's that going to leave me with? C squared on the bottom. Done. Anybody get that? What did you do wrong? What now? What did you do wrong? Okay, so then here's the deal. Let's practice this one right here, right now. Let's go x to the negative 5th over x to the negative 8th. Do that one for me right now. I want you to get rid of the negative exponents. I want you to give me the answer to that thing. Flip them to the proper side, and then just reduce, right? Then just fix it. Then simplify. Flip them to the right side first, then simplify. Another thing you could do here, let me think about this. What does that equal? Anything over itself is 1. So I can eliminate them, right? So technically, couldn't I, with this, say that there's 5x to the negative 1s on top and 8 on the bottom. I eliminate them, and so that's going to leave me with x to the negative 3rd on the bottom. Do you see what I'm talking about? Well, then what do I do with that? Flip it up, x to the 3rd, I'm done. See what I'm saying? Like, it's just you got to wrap your brain around this. There's lots of ways to get to it. Just you got to wrap your brain around it. So here's the deal. If you did it the long way and really wrapping your brain around it, then this becomes what? X to the 8th, where? On the top. And this becomes x to the 5th on the bottom. When I reduce this, when I eliminate them, that leaves me with x to the 3rd on the top. Did you get x to the 3rd? Okay. Makes sense? Okay. All right. There's nothing harder than that. Oh, one more thing, really quick. Do this one for me. What is that one? Is the answer 1? No, this is very important. The difference here is that what is to the 0 power? Just the y, right? Just the y. If I wanted the whole thing to be to the 0 power, what would I have done? I would put it in parentheses, right? If I wanted the whole thing to be in, now this whole thing is 1. But because I didn't do that, and it's like this, the only thing that's 1 is this y right here. Make sense? That's the difference. Just wanted you to see that. And so then, what would this be? I would flip that x, negative 2, to the bottom, making it 1 over x to the 7th. Does that make sense? Because that y is just a 1. Make sense? Okay. I'll give you your homework. Page 413, 19 to 42, even. Yeah, that'll do it.